Okay, so what we're talking about is the difference between an endothermic and an exothermic reaction. So if I have barium hydroxide and sodium nitrate, and this is the assumption is that these were the two things that if you put them together, they got really cold. They're like an ice pack. So what we would actually be doing is saying plus energy, because they're absorbing the energy to make the reaction happen. And then they're going to give us barium nitrate, BaNO3, 2 plus sodium hydroxide. And this could be two of those. BaNO3, two of those, two NO3s, two NAs, two OHs, two OHs. Perfect. So if you have energy coming out on this side, or energy added to the reactants of a chemical reaction, so this is the reactant side, reactant, and this is the product side. So if you have energy on the reactant side, energy on the reactant side is endothermic. If you have energy on the product side, it's exothermic. So if you have this plus energy yields this plus this. That's just going to be an endothermic reaction. If instead you have this plus this yields this plus some energy released, then it's exothermic. So wherever the energy is on the equation, if it's on the reactant side, it's endothermic. If it's on the product side, it's exothermic. Does that make sense? So if it requires energy for it to happen, it's absorbing energy, and it's going to be cold. And if it instead, as a result of the reaction, releases energy, then it's going to be hot. That's going to be endothermic or exothermic. So if energy is with the reactants, it's endothermic. If energy is with the products, it's exothermic. Simple, right? All right, last thing I think we're going to cover, and then I'm going to turn you loose on an assignment. So the last thing is the difference between and the similarities between accuracy and precision. So accuracy versus precision. Okay? So if we have let's say we have a target and we're trying to get into the bullseye, and we land a mark there, then that mark is accurate, but it can't be precise. Because precision is reproducing the same result. Okay? So we can say, all right, so what if we landed 4 or 5 different results in there? This is accurate because it's in the middle, it's near the accepted value, and it's precise. And precise is to say we can reproduce those results over and over. So in other words, there's a cluster in the same place. So that would be accurate and precise, A and P. So both A and P, accurate and precise. Now, what would happen if, let's say we shot at the target and we had 5 land over here? Somebody trying to FaceTime you? FaceTime? You should have answered it. We could have all said hi. So what happens if I have 5 over here? What do we have? It's precise, but it's not accurate because it's not near the accepted value. So this little cluster right here is precise, but not accurate. Okay, so what happens if we have 5 shots like this? Neither of them. It's not precise and it's not accurate. But what happens if we have the 6th shot and it lands right here? That shot is accurate. Does that make sense? It was inside that range of accepted values, so that shot is accurate, but the collection of shots is not precise. So you have an accurate single trial, but out of your 6 trials, you're all over the place. I'd rather see this than the green. So I'd rather see that at least you're consistent, because now you can blame it on the lab equipment or the conditions or the atmosphere or whatever it is. You can blame it on some external thing because your results keep producing the same thing. Your actions keep producing the same result. So that's precise. That's good stuff. Okay?